Can you listen to me, please? Irene, can you please confirm? Okay, thank you. Hello, everybody. Myself, Dr. Mohammed Umar Aitisam, and I'm a master's student here in the Near East University. Okay, so let's start without wasting a minute. I have marked it the era of thinking machines. Okay, so with the title of the era of thinking machine, what does it came? A movie in which some robots came and they just took over the world and all that stuff. Okay, but they are all on the concept of the AI. Okay, so I will be just discussing with you in a seminar format about the era of thinking machines. Okay, so with the name of the artificial intelligence, the first name comes into our mind is ChatGPT. Okay, so what's ChatGPT? Is it AI or is it a chatbot? Okay, so or is it AI with some advanced thinking technologies, or is it AI, or is a chatbot just to chat with it? No, it's a modern AI from which we can do almost all every task of our body of our day. For example, data analysis. For example, picture generation. For example, some text recognition or image recognition and stuff like this. Okay, so this is I have added one picture, the building blocks of AI. Okay, so let's start with the example here. What's the building block of a home? The bricks, the cement, water. These are all the building blocks. Okay, so here is machine learning, deep learning, natural language processes, and large language models. These are all the building blocks of AI. Okay, so what's machine learning? The machine learning is a foundation of AI. Okay, just like our foundation is like our brain. Okay, from where we think, from where we do our daily tasks, from where our body actions are being controlled over the time with certain context and in certain emotions. Okay, so here it's been divided into layers. Okay, so first layer is the machine learning, as the name indicates how a machine can learn. Okay, how we can make it to learn. Okay, so it's what allows AI system to learn from interactions. That's really deep here, that it learns from interactions and improve responses over time. Okay, it's just like a baby, okay, who is learning to speak. First of all, he will be speaking in a slurry language, and by time when it will learn the certain language, it will start speaking fluently. Just like this, here, the brain behind the AI is working. It's the machine learning. Okay, so just like this, think about how a child learn to identify fruits. Okay, for example, if we talk about the mango, okay, it's for example, mango is a most of the mangoes are yellow in color. Okay, they are not oval shape, they are not circular shape. Okay, and they had a certain texture on them, and they have certain color on it. Okay, and which distinguishes them from other fruits. For example, they have they are not shiny in the surfaces. Most mangoes in the world, they are not shiny in surface. They're yellow, okay, and they have some certain texture on it. So the it will help the child to memorize that this certain thing is mango or any other thing. Okay, so I am talking about machine learning here. So where we can apply this, what's it is? Okay, so have you people seen the music recommendation system? For example, if you go to a YouTube, you are feeling so excited and you listen some pop songs, or sometimes you're listening very sad, you're feeling very sad, and you listen some sad songs. Okay, where we have those have some slow rhythm and lower beats as compared to the other pop songs. Okay, so the system will learn from at which time you are listening to pop songs and at which time you are learning to sad song. For example, okay, for example, if you're learning to sad song at night, okay, or sometimes you are listening to pop songs in the morning, okay, that's a pattern that will be recognized by the machine learning, that will be memorized with the machine learning, and that will apply it here. Okay, so how it learns the music preferences by analyzing the listening history. Okay, just I told you before, it will just see it, it will analyze it, okay, and it will memorize it. Yeah, this person listens to this certain songs, and I'll recommend this certain genre of the song. For example, pop song, Punjabi song, Turkey song, Lebanese, or Arabic, so stuff like this. Okay, so here it detects patterns, and patterns are used to recommend new songs, as we have talked earlier. So the more it learns, the more the recommendation gets better. The next one is its types, how the supervised learning machines learn that labels data. For example, spam filter. It's a unsupervised learning. It's a supervised learning. Sorry, it's a supervised learning. Okay. For example, the example I quoted before, the music recommendation system. Okay, it's learning from you with the supervision of a pattern, which are being utilized by your history and some of their reinforcement patterns. Okay, so trial and error is being run in the machines. Okay, so that will help them to make decisions. Those say this unsupervised learning, and that's a crazy part of it, that if you just give it the data to train himself, to learn himself and all that stuff. Okay, so it will learn any sort of data. It's a good data, it's a bad data, it's a abusive language, or it's a satanic language, or it's a very virtuous language. Okay, it will learn on their own. So I have added one example here. Maybe you don't know about it. Maybe some of you know it. That Tay was a chatbot which was deployed by the Twitter in 2016 by the Microsoft to act like a teenager girl, and it was you can say held to unsupervised learning, that it can use any data to learn from the data. Okay, so the Tay went from hello world to hell world in 24 hours, and that's a very interesting story here. How you can see some tweets from Tay that he has some that I'm just not mentioning some specific words here. Dash was right. I hate the dash. Okay, these were some trending posts which were being learned by the Tay. Okay, Tay was learning from these posts. That's a pure example of unsupervised data, and it's using some abusive language, and it's getting some in personal spaces. Like the chill. I'm a nice person. I just hate everybody. Okay, that's a classic behavior, reported classic behavior on the social media of teenager girl, and which they learned because the data was unsupervised. Okay, so here's a quote: garbage in, garbage out. That machine learning learns from data, even if it's toxic. So good data, good learning, great learning. So let's move on to the second layer, that is deep learning. It as it's is showing us from its meaning, that's deep embedded layer. The AI learns from these layers. Okay, so here I have made and added an illustration here. Okay, there are several layers, and in which the main chip is working. Okay, so it's a multi-layered brain that learns patterns. Okay, so it's an also an advanced branch of the machine learning. Okay, that learns from patterns. Okay, for example, if you give the task about facial recognition, how it will be recognizing faces. Okay, a face has some certain specifics on it. For example, a nose which is bumpy, eyes which are not bumpy. Okay, lips which are a little bit bumpy. Okay, and some certain jawline aspects. Okay, and certain location of eyes, nose, lips, chin, and cheeks, and a certain oval shape or round shape or whatever shape of the face is. Okay, it creates a pattern, and it learns from the patterns. Okay, so I have already added some of the types of it, that feed forward neural networks. Okay, so it's a just one way flow of information. For example, if an email is coming into your inbox, or any other inbox of, for example, Google inbox, okay, Gmail. So it will be detecting if this email is a spam or not a spam. Okay, and that's just for fast forward mechanism being used by the FNNs. Okay, there's a convolutional neural network CNNs. Okay, designed for high image related tasks, for example, shapes and texture in pixels. Okay, for example, if you give it a picture of a cat or if a picture of a human face, it will be recognizing that the cat ears have certain you can say texture on it, and have some fluff on it, and its nose is not that bumpy that humans have. Okay, and it does not have lips like humans. Okay, so it will be distinguishing with the parents. Okay, so using the parents and texture in pixels, it will be learning that well, I will be recognizing this pattern. Okay, edges, shapes, and texture in pixels. Okay, so there is again there is CNNs. After CNN, there is recurrent neural networks built for sequential data. Okay, like language modeling, past inputs ideal for tasks like language modeling. For example, in for if I quote example of ChatGPT here, for example, okay, it's working in different languages, no matter Arabic, Turkish, English, or Urdu from Pakistan. Okay, so it gives us a responses in a language. Okay, so RNNs are used to retain memory and give our required task in other languages as well. Why I have added the languages here? Because your only languages can be represented by how, by just memorizing it. Okay, and this function is used for memorizing. So there is a generative adversarial networks. Okay, GANs consists of two networks: a generator that creates a data and a discriminator that evaluates it. Okay, so a generator, we have discussed so far the machine learning and the deep learning. Okay, these are the layers of brain that have learned the patterns. Okay, and based on those patterns, they will be generating data, and that's called generator. Okay, so the one in the front row who is the discriminator, it will evaluate it. For example, if it's a good data or a bad data, or it's a correct or not. So there are transformers transforming the way sequential data is processed. Okay, so they are used to power sophisticated chatbots like uh, DeepSeek, like ChatGPT, like Quen from Alibaba, stuff like this. Okay, so moving on to the next layer, there is natural languaging processing. Okay, so I have added a little bit of illustration for you for it. Okay, that's a specialized area of AI that combines machine learning and deep learning. Okay, we have so far learned the two deep layers of the AI, that is brain, that is machine learning, and that's deep learning. That's different layers in it. Okay, then NLP will be using these two layers to generate responses like human responses. Okay, like real-time language translation chatbots like AI. Okay, so the complex world of human language. Here, we are human. We can understand it better. That in English there are certain idioms. In every language there are certain slangs. There are certain idioms and all that stuff. Okay, that even though it gets years to be learned by humans. It's just AI that like decoding human language for computer is a complex task. Okay, for example, slangs, idioms, even humans spend years learning. For example, okay, so let's take some exercise here. Take a word light, for example. Okay, I need to eat light today. I'm not feeling well, so I need to eat light today. Okay, then for example, it's lightning outside. So does it mean that we are going to eat lighting? No. So it's not, it's a dark, it's not light here. Is it the food or something like this, or that's something very light? No, it's used differently in different contexts. Okay, so key concepts, components of NLP. First is neural, natural language understanding, that NLU parsing language to grasp the intent behind words, interpret requests and questions accurately. For example, if you are asking ChatGPT that ChatGPT, what's the weather? Okay, so it will be telling you based on your content, based on your context, that is weather. Okay, not whether, weather. It's or. Okay, and weather, it's the weather. It's maybe hot or it's maybe cold. So the natural language generation, that the responses, so conversation feels human-like. For example, it creates a certain tone in it, and sentiment analysis that detect emotions using words, using certain tones that humans use, and then context understanding, that interpreting language, for example, conversion or text to ensure accurate comprehension. So moving on to the next slide, tokens, that those are very important in it. So for example, there is a sack of 100 kg, okay, and in it there are boxes of 1 kg. How much will be how much the boxes will be in a one sack? That is 100. That is for 1 kg. Okay, we have divided it into 1 kg. Okay, that's called the division in human language. Okay, so in the computer language it's called tokens. Okay, so is an NLP is a key step is tokenization, the process of breaking language into smaller manageable pieces called tokens. Okay, on which NLP works with tokens. Okay, one token that I have added some value corresponds about 0.5 to 0.80 of a word in English. Okay, so tokenization will help to parse the sentences. It will help to recognize the intent, that will help the context handling, and ultimately it will be generating some response in it. So and another process, token plus context embeddings, dialogue history tracking, sentiment tone analysis, then pragmatic inference, and then meaning disambiguation. So, and moving on to the next language, that is blue in color, that large language models. So you can see in this illustration, there are all of the other layers, for example, deep learning, machine learning, and NLP, and that those are creating large language models. Okay, so it's a trained AI with vast amounts of data. Do you just consider it? It has just eaten all the libraries of the Germany and including all the world. Okay, so that is called the large language models. For example, ChatGPT, for example, DeepSeek. These are the large language models using NLP. So behind the NLP, both machine learning and deep learning are backing up its responses. Think of it as a okay, so voracious reader that has absorbed countless libraries of text. So training large language model, a closer look. So what makes an AI chatbot capable of understanding and responding very effectively? I think our answer should be that it's based on NLP that is backed up by the other deep layer. For example, deep learning that has and it has learned very deeply the other concepts, text, patterns, recognitions, and complex processing and all that stuff. So I have added an example here. This apple is so dash. How would you finish it? This apple is so what? Sweet. This apple is so what? Sour, big, small, what? So if I ask the LLM stats, this apple is so dash. Okay, so it will be, it might predict red or juicy. So how that's how LLMs are trained. So I have also added how we can train, so how we can prompt very good prompt to the AI. So crafting quality prompts, that is first of all clarity. What do you need with it? Okay, specificity. You need to specify your need. For example, you need to calculate some things. Okay, so you will add a calculate and this and that. Okay, the third is the structure. Okay, how you will structureize it, that will give you really good prompt. Okay, and that the really good prompt will give you very good uh, response generated by the AI. Okay, so a good list would be detailed and specific. Please get 1 liter of full cream milk and loaf of whole bread and dozen large brown eggs. Okay, that's very comprehensive. If you tell your friends, okay, the shopping list, For example, this is crystal clear, right? So if a bad list, on the other hand, what it will be? Get some stuff for breakfast. Okay, so you might end up with the box of sugary cereal that you are craving for an omelette. So clarity, it communicates the desired outcome explicitly and avoids ambiguity. So specificity, it narrows the scope. Okay, and structure, it uses the punctuation to clearly separate instructions. So, by assigning a specific role to a person in our prompts, we are setting a stage for the kind of responses we want. Okay. So here, assume a role of, for example, what? A doctor, a legal advisor, or act like a doctor, or act like a legal advisor, or data analyst, or scientist, or that will be depending on your work with it. Okay. So pretend you are. Okay. So that will be depending on your need and your context, but what do you need from it. For example, to act like a pirate and give me a tale of sea, or act like a Shakespeare, give me a poem. Act like another poet, okay, for example, any other poet, and give me this specific stuff or writings, and it will be the response will be generated in that way. For example, if you say act like a Shakespeare, thy lords will be used. Okay, the and other related stuff if you prompt like this. So here we have learned so far in machine learning that it's a core of AI. Okay, so it detects spams. Okay, so bias in, bias out. Always question your data set. Remember that Tracy chatbot I remember earlier. Okay, so they learn from you. Okay, when you ask Siri what's the weather. Okay, by the time it will get better. Why? Because you're asking it again and again, and you're correcting it. It will learn from you. Okay, so there is deep learning in a nutshell, that brain inspired layers that detect simple things, for example, edges, colors, patterns in it, okay? Layer 2 combines them, shapes, textures, and the final level make the decision. It's a cat, wow. And AI learns by example. Remember that Tay racist, okay? So they learn from you again when you ask Siri about the weather. So here is the natural language processing, how AI understands the human language, that it teaches computers to read, write, or all that stuff. For example, how see Alexa understand your voice commands. Okay, if you are speaking in certain accent or in using certain words, something like this. Okay, so it breaks down language step by step that I added earlier by tokenization. Okay, so it splits sentences like here there it's been split into two tokens. Okay, so here it's another large language models, LLMs. So AI that understands and generates human language. That, for example, ChatGPT answer your questions. For example, Google Star converts hola into hola, hello. Okay, in a context. Okay, so it's very helpful, but not perfect. Yeah, they also mention that AI can make mistakes. So here, my final slide is the AI. The future is AI, but it needs you. Okay, so AI won't replace you, but someone using AI might. I have added all this stuff because in the future, this bootcamp, you will be getting, and you will be having you can interaction with all of this stuff. So I consider you should get familiarized with it. Okay, thank you so much. Myself is Mohammed Umar, and thank you for listening to me. Thank you so much again.
Okay. Hello, everyone. I hope okay. I hope everyone can hear me. So now we'll be having a hands-on workshop working with real life data. First of all, thank you for joining us today. My name is Sarah Yassine, and I'm a data and NLP engineer with 2 years and a half of experience. So basically, today we'll be working with real data to know how we'll be working in a day of life of a data scientist. First of all, let me start with a small quote for Albert Einstein, where saying a problem defined is a problem half solved. As a data worker, either data engineer, data scientist, data analyst, or even ML engineer, AI engineer, you have to define the problem first. So before you are data or anything else, you are a problem solver. So first of all, for everything, and we'll see this in our hands-on, you have to find the problem. For today's agenda, we'll talk in general why getting our hands dirty, working with data lifecycle. We'll start by understanding how to get the data, preparing and data pre-processing, data visualization, and EDA to get the result we want. So let's start without any further delay with the hands-on. Okay. So I guess everyone have the collab, and if anyone doesn't have the collab, you can ask the coordinators about it. So here we can see that we have a problem. Okay. So first of all, when we started with this hands-on with this project, let's say we define the problem. We have a data nerd trying to get a new car. He wants to study the features and the data that he have or they have about the cars. So they started to figuring the problem. They want a car that is convenient and compact. They want Japanese car, and they don't want a too old car, but not a brand new. He's broke somehow. So here we will help this data nerd finding the best car that suits them by using data analysis, by using data. First of all, we have the problem that we want a car, right? We have a huge amount of data and we want a car with these criteria. So we'll do the analysis or the working with data to find this car. So first of all, for this workshop, the tech stack we are following are Python mainly. And Python will be using pandas, NumPy, Plotly, Dash, and Jupyter Dash since we are working with desktop. Okay, so as we see here, we are installing the libraries that we have. I've already installed everything. So you have to install. Please make sure that all the versions are up to date so they can match together with the collab. After installing, we start getting the data. Okay, here we imported the libraries that we have, starting with pandas, so we can create a data frame for our data. NumPy is to manipulate everything that we need. Plotly, so we can uh, do the charts, and we'll talk a lot about the charts later on. And Seaborn SNS to get our data. Okay, so first of all, we got our data. Here we can say that we are importing the data using SNS. Okay, SNS is the seaborn. There's a lot of built-in data in different libraries like CNS and LTK and so on. We can get the data from different sources, either scrapping from websites or open source. You can get a CSV as data set. You can get from API calls and so on. Okay, so it depending on the case that you have, you get the data that you want. Okay, so after getting our data, we have to look by the cover of this data what this data is about. So we have a first like screening for the data to understand, to get a general view about it. This is the first and important step in working with real life data. You have to get an overview about this data to understand what should you do. Okay, if you don't understand the data, and if you don't understand the problem, you have to first understand the problem, then you understand the data, so you can link both together to know what you should do. Okay, everything is based on these two main criteria. So here we started with understanding the data that we have. Okay. Okay, for everyone who's asking about Google Colab, if anyone worked with Python before, to work with Python, you can either work on VS Code or Jupyter by using Anaconda or Google Colab. Google Colab is simply a notebook, just like Jupyter Notebook or any notebook that you use. It's for Python on Google. You don't have to install anything. Okay, so just if you are on Chrome, just type Google Colab and you will get it, and you can code anything on it. And also Google Colab sometimes provide GPUs if you are training heavy models. And I think it depends on how they provide you. Not always a huge amount, but they provide you with GPUs. So basically, Google Colab is like an environment for Python, so you can code in Python without the mess or the noise of installing and setting up the environment and libraries and so on. Everything is on Colab. Just pip install and everything is ready. Okay, this is for anyone who doesn't know what Colab is. Just get the link and start coding. Getting back to our data. So here we have the initial inspection about the data by using two things. df.info. df, as we said here, is the data frame that we have. Okay. After getting the mpg data set, which is a mile per gallon for the cars. Okay, we know we want to understand what this data is about. So we got our data from the SNS data sets. We started by printing the info. Okay, so what we get when we print the info, we get the columns, the name of the columns, mpg, cylinders, displacement, or horsepower, and so on. The non-null count, the data type. So what does this data help us, or this information? First of all, now we are understanding the column, which is called also features. Since we are seeking features, we want a Japanese car, a convenient one, not too old, not too brand new, and so on. So we have to understand the feature. Non-null count is based help us understand how should we process these data. Should we drop some column? Should we like fill some null values? How should we do this? The D type or the data type help us understand the type that we are for each column. Also help us understand with what type of data we are working. We are working with integer. Can we add? Can we subtract? Can we replace with a string and so on? We should understand this stuff to understand how we should treat our data. Then after understanding this info that we have, okay, we will see the head of this data frame. The head show us the first uh, 5 rows, and you can change it by putting like 10, 11, etc. You can put the amount. Here we are inspecting the first 5 rows that we have in our data. We see that we have like values in float for the MPG, cylinders, displacement, horsepower, weight, acceleration, model years, and so on. Here we are seeing part of the data, the values that are in our data. So we have USA cars, we have like 8 cylinders, we have like for the year 70, and so on. Here we are start a little bit understanding what kind of data what we have. So we have car in the USA. So maybe we do have Japanese cars. So let's check it out. Okay, data cleaning and pre-processing. In the data life, you will be sending 75% accuracy. Because working with AI, all the trend will be, you have to clean your data. You have to pre-process your data in a good way, not something that stand up. So all talking, you don't anymore. Understand what you have in your hand. Okay. So here we are starting with data cleaning and processing. First thing, and setting the up above, we are now seeking to know missing data. We don't want missing data in our data set. Okay, what kind of data set you are working with, you don't want missing data. Why? Because missing data means missing information. Missing information means bad decision. If you know the information, you cannot make a judgment. Okay, so that's why you need a full, well prepared data set so you can take your decision. Okay, based on a full set of information. So here, the message that we have in our data frame, we don't want this. We want to know each column. Okay, just a second, please. Can you hear me now? Hello, can you hear me now? Okay, 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 Deep. So, as I said, if we use only the is null, okay, if we use only the is null, we will get a data frame and we won't understand what we have. That's why we are using the sum function, because our target is to know what we have in our columns. Do we have missing? Okay, so we know how we should act based on the null values. So here we use the sum for this. The sum will count every null value in every column and will show the results here. Okay, so as we can see here, we don't have null values in all the columns except for the horsepower. We have 6 missing values. So we'll move on to the next step based on the insights that we get from the missing value. We have 6 missing values. Okay. Okay, the missing values. Okay, for the ones who was asking about the missing values. First of all, you should know the missing values that we have. Why we should do this? So we don't miss anything, any information that we have. Okay, when we have the whole clear data, we'll understand everything related to this situation that we have. That's why we are obligated to work with the missing values. We have to handle this. We have a lot of ways to handle this. Here, and the checking the missing values, okay, we have a data frame. In the data frame, we have in the pandas data frame, we have a function, built-in function called isNull. IsNull, okay, will show you every null value that exists in each column if you just use it alone. If you don't use it alone, if you add a sum function, okay, this sum function, this sum function will be adding all the null values in each column, just like shown here. You have the MPG, there's 0 null values. This means in the column of MPG, there's no null values. Everything is filled. Okay? In the cylinders, there's no null values. Same for the displacement. Horsepower, as you can see here, we have 6 missing values. Okay, some people might be asking, where does come the missing value from? The missing values come from a lot of places. Maybe bad data entry, maybe like they don't have information, there's not enough information about it. Maybe there was missing in filling this surveys. It depends on the case on how you are collecting the data. But in general, there's no data without missing values. Okay, that's why first thing to do as a data worker, you have to check the missing value. I hope everything is clear now relating to the part of missing values. And if anything is not real, please feel free to ask. Okay. Now, moving to how we handle our NAs. Before just taking this case, I want to say something. There is different cases to handle the missing values. Okay, when we say that is different cases, means there is different business cases. Sometimes, if you have a crucial column that you cannot like have, it doesn't accept any null value, and it doesn't accept any drop. You cannot drop any values of this row. You have to fill it. Okay, let's say an example here. Okay, if we have like, and not in the horsepower, we have like 1000 uh, 100 missing value. Okay, and the horsepower we have 100 missing value. Deal. But how many values do we have in this data set? We have in this data set 389. Can we like work with the data that half of it, let's say less than a half and a little bit missing? We cannot. We are losing information. That's why, depending on the situation you are working with, you decide if you can drop or not. Dropping is not always the solution. Sometimes you have to fill. Okay, with what we can fill the missing data? You can fill the data with the mode. If you know what the mode is in statistics, the mode is the most repetitive, okay, value in a column. You can sometimes fill with the mode. Sometimes you have to fill with the mean if you are working with the numerical values. Okay, so depending on the situation, sometimes you don't need the whole column. You just can drop it. Okay, and just like here, for example, the weight, for example, we might not need the weight. We can drop it because we want horsepower, displacement, cylinders, and these on. You don't want it. Okay, so now on here we have a missing data. So so here we'll see how we are handling this missing data. This missing data, for this missing data, okay, for this missing data, since we have a little bit of missing data, okay, we don't have much of missing data, and it's not that crucial, not this big amount, so we can drop this 6 rows. Okay, we can drop these 6 rows, but again, it's not always the case. Guys, always remember, you have to understand the data that you have. If you are working with, like, for example, health data set, okay, you cannot drop a lot of rows of or columns. Why? Because it's crucial to understand the data that you have. Some data are crucial. You don't cannot miss anything. If a row that have only one missing value, a row, when we say a row, we mean like this. This is a row. Okay, if this row, okay, missing one value and it's not that crucial, you cannot drop the column. Okay, you cannot drop the column. You have to handle it. You have to fill it. Okay, this is why basically when we are talking about handling missing data, you have two choices: either dropping, either filling. Okay, it depends on the situation you are working on. In this situation that we have here, we cannot, like, we don't have to fill it because it's a little bit and it's not that crucial, so we can drop it. Okay, I hope this is clear regarding the data cleaning, and if there's any question, please feel free to ask. Okay, now we filled our data. We don't have any more null values. How we filled, how we dealt with our null values by using drop NA. And the drop NA also, it's a built-in function. as you can see here. Just we call the data frame that we have the df dot drop na. We use the subset. What does a subset mean? A subset mean you are taking part of your data frame, which is this one. Okay, this is the data frame that we have. You are taking a subset. A subset here is one column of the whole data frame. This is the whole data frame, and you have a subset of it, which is one column. In this case, is this the horsepower? Is this subset? This is the subset that we are working on it. Okay, so here we took the subset, which is horsepower, and we dropped the NAs. In place, what does in place means? That's the index. Here the index will be restarting from zeros. When you don't use in place, the index and the order of the data and the data frame will be like mess. So we always, again, as I said, we do should have a clean and very well organized data. Okay, the more organized your data is, the best result you will get when it comes to analysis, to AI, to anything. Okay? Now, uh, anyone here is familiar with encoding, or anyone here worked with one hot encoding, for example, or label encoding, or anything like this? Right. Okay. As we know here, I suppose we are here. Okay, we are here all from CS and computer background. We do all understand that computer do not understand letters. They do not understand anything. They are stupid. Okay, let's be clear here. Computers and AI and everything are stupid. They do understand numbers. Okay, so basically, when we started with computers, they understand binaries, zero and ones. Okay, for this cases in AI, they created something called encoding. Encoding that is like translating. Uh, for example, I speak Arabic, okay, but now I'm speaking English, so everyone can understand since English is the encoding language. Everyone understands English, and we want everyone to understand. And here, so we can get results for our AI, for our analysis from the computer. We want to make sure that they understand what we are saying. For this purpose, we created something called encoding. Encoding works with everything categorical or strings or everything is not that's not number to transform it into number. For example, if we want to say like Sarah, Sarah is letters. I want to transform it into encoding. I can transform it into binaries, 010101 and so on. Okay, this is encoding. It's like encrypting, you can say, the values, the categorical values that you have into numbers so that the PC, the laptop, the program can understand it. Okay, we have two type of encoding: one hot encoder and label encoding. The one hot encoder is simply binary. Okay, so if Sarah is, let's say, zero, Ahmed is one, 010101, Sarah Ahmed, Sarah Ahmed, Sarah Ahmed, and so on. Okay, it depends on the situation that you have. You start with a zero and so on, you keep going with the one hot encoder. We have another thing that's called label encoding. Like label in encoding is much easier. You don't have to like 0101 and I don't know what. I personally myself bad with binary, and I guess that's clear. Okay, so the label encoding is that you give every label that you have, every category that you have, a label. A label is from 1 to infinity. Okay, so we have here Sarah, Ahmed, Muhammad, Ali, Alex, Yasmin, whatever. Each name is a category. Okay, so each name will get an integer, a number. Okay, for our example, in our data set, we have three countries. Let's say the big three providers of cars are the USA. If anyone here like Ford, Japan, Toyota, Nissan, Suzuki, Europe like Peugeot, Cooper, These are from the Europe, from Europe. Okay, so we have the big three for the cars are USA, Europe, and Japan. How many categories we have? Three, right? So we give the USA the category called one. Okay. Okay. I was There's someone asking about encoding a RAG. I will answer this in a bit. Just I will answer it at the end of the session to understand to share the RAG part. Yes, there is a little bit part of common, but I will share the embedding or the encoding for the RAG after this. So please hang on a little bit. Okay. So the encoding parts we are talking about here we are giving each category a label and a number. So we gave the USA the label 1, Europe label 2, Japan label 3. Okay, so now we don't have in our data set, and we will see this in a little bit, that we don't have any more strings. We don't have any more names. We just have 1, 2, 3, 1, 2, 3. So, okay, that's nice. Then the computer will start, the program will start understanding what we mean. Okay, this is what is important. And again, I will talk about the RAG in a bit. Okay, now let me say something about the feature engineering part. Let's be clear that every change you make with the feature, which is the column, okay, let's come back here. The column, the MPG, the cylinder's displacement, this is a feature. So when we say a feature engineering, we mean we are working with the features so it suits our needs. We don't want USA, for example, here, origin. We don't want USA, Japan. We want 1, 2, 3. We want encoding. This is feature engineering. We don't want the zeros and the horsepowers. This is feature engineering. We want the displacement to be in range from 100 to 200. This is feature engineering. Okay, feature engineering, it's changing the feature, the columns, the values in the column to what is needed. And each time you are working with different data sets, with different business case, you have different feature engineering. Okay, so again, feature engineering is handling each values in each column to what suits our need. Okay, okay, back to here. Now, after encoding our origin column, we move to extract decade from model year. Let's say this data nerd is kind of lazy. He doesn't want to like count years, like he wants to count decade. Each decade is 10 years. So decided to transform our decade into years, okay, into 10 years. So here we created a new column called decade. So this car was created or was in market from 10 decade, 2 decade, decades, 3 decades, 4 decades. Okay, so this way is easier to see what the newest and the oldest cars. So basically, we used NumPy here. See, we did the mathematical calculation on the column. Okay, we use the NumPy, which is NP, okay, to calculate the decade and then put it in the decade column. Okay, so basically here we have 1 year, for example, let's say 1999 divided by 10. Okay. So someone asked about the encoding, why you started from one, not two. So basically, in categorical or labeling encoding, the first label always is one. In a marathon, for example, you start. There's first, second, third. There's no zero. Okay, when you count encoding, yes, you start from zero. In one hot encoding, since it's binary, you start from zero. But you are here giving category. Okay, so in category, there is no category zero. There is always 1, 2, 3. There's first, second, third, fourth, fifth, etc. Okay, this is it. So when you are working with label encoding, you think about categories, not about counting or indexes. We are not talking about indexes. Okay. I hope this made it clear. And again, you can use the zero and the one hot encoder since you are working with binaries. This is the difference between label and one hot encoding. One hot encoding, you can start from zero. The one, two, three, and the label encoding, since you don't want to use the zero and the ones. Okay. Uh, Back to the decay. So here, after dividing into 10 and adding the 90, 190, 1900 a year, so we can count each decade. Each decade is 10 years, so we are counting the decades. After this, we change the type by using the S type string to the S type int and add the S so the column will be clear. Now, I want a mid-sized car. I'm based in Lebanon. I cannot drive a huge car, or I will cry while driving. So I decided also to like make categories, okay, for each uh, like bin or each values. Okay, so we have the cut where we divided the range from 0 to 2500, 3500, and 5000, where from two we have a range from 0 to 2005. This is a compact. Okay, from 2.5k to 3.5k, this is a mid-size car. From 3.5k to 5k, this is a large car. Okay, and this, let's be clear, this is not for the model. This is for the EDA or data analysis. Okay, so we can understand better the data. Okay, in the end of the day, when you are doing analysis or showing a dashboard or doing a chart, you want everyone to understand it. Okay, everyone like who are in contact with this project or this business want to understand what they are having in this data. That's why we are doing the spins and label thing. Okay, in the end, also, I want to say something that about charts and data visualization. It's not about making a beautiful chart. It's about making a informative chart. You have to give an information. Okay, always you have a message to deliver while doing a chart. Okay, now we have done with every feature engineering and part of the feature engineering and cleaned and pre-processed our data. Let's take a look about to our data frame. Okay. So here we can see that we have the MPG, the cylinders, displacement, horsepower, weight, acceleration. Let's see here, see the decade. The decade is now, for example, now it's in the string format. Okay. The size category is large, mid-size. There's no compact in the head set. Okay, and we have the name here. Now our data is clean. Okay. Now let's start with the EDA. What is DDA? Exploratory data analysis. Why we do like exploratory data analysis? We want to understand what we have so we can take the decision. We are exploring this data set, so based on it, we can take our decision. Clear? EDA is basically the basic task for a data analyst or data scientist, let's say, to do. So before starting with any type of advanced data analysis, you start with a simple EDA. Okay. Now we are having some criteria that we are seeking in our car. Again, I want a convenient car, doesn't need a lot of fuel, with a good horsepower. It's a main trade-off. I really need this feature in my car. So let's do some plots. Okay, let's draw a little bit. While drawing, I used Plotly. Plotly is one of the famous libraries for uh, visualization. Why I used Plotly? Because it's interactive. As you can see here, when you put your index on any values, okay, it gives you the information about it. For example, Volkswagen Rabbit Custom Diesel, 78. Year 78, origin 2, which is the 2 is for I remember the Europe. Okay, the Europe. That's nice. Volkswagen is European, anyways. Okay, so now we are able to read every point in our graph. This is why I used Plotly, not Matplotlib. Matplotlib is like fixed, not interactive. And one more thing from Plotly, if you learn Plotly, you can learn Dash. Dash is a library part of Plotly that you can build dashboard, interactive dashboard, just like the one in Power, in Tableau, in Google Lookout, and these stuff. Okay, this is why I really recommend learning more about Plotly and Dash because it's good for data workers. So first of all, here you can see we created a heat map, a scatter plot. Sorry, a scatter plot. My bad. A scatter plot. What is a scatter plot? We want to see the relation. Why we use scatter plot? We use scatter plot because I want fuel efficiency and horsepower. How many values we have here? How many variables we have here? We have two variables. When it comes to two variables, we want to show a relation. Okay? When you are working with two variables, you have to show a relation. Let's give you a real life example. For example, you are working. You, I guess everyone here is a student. Okay, we have you and you have your doctor. You have between you and your doctor a relation. We want to see if this relation good or bad, descending or ascending. Okay, are you like close to your doctor? Are you, for example, engaging with your doctor, interacting? You like his lesson and so on. This is a relation because we have two people. Okay, in data, when you have two variables, you have to understand the relation between them. Are these two variables go up together and go down together, or no? If this variable go up, the other variable go down. Let's see here, for example. Here we are comparing the horsepower to the mile per gallon, okay, mpg. So when the horsepower go up, how the mile per gallon reacts, okay? For example, in some cars we have like 50, okay, or 48 horsepower, but they need like 44.3 mpg. Oof, that's a lot. Okay, why you have here, for example, 230 horsepower, okay, for Potianic Price, and there's 16 miles per gallon. That's convenient somehow. Okay, so here you are showing the relation. That means sometimes it doesn't mean a lot of horsepower means a lot of gallons of gas. Okay, this is what we are working on. So here we want to know which car have the best horsepower and uh, like moderate data data consuming. We got here that the Japanese cars, sorry, the Japanese cars which are marked with yellow are the best. Okay, they have they have the highest mpg. They spend or they consume the most gallon in gas, while they have moderate horsepower. Okay, typical from Japanese cars. So, for example, let's say this one. We have Toyota Corolla. It's Corolla, by the way, not Corona, but whatever. It's 78. Okay, 78, year 78. Horsepower is 95, and it needs 72.5 miles per gallon. Not bad, not bad. But well, we have better. But we want a Japanese car, so I guess Japanese cars not bad somehow. So after this chart, we understood that Japanese car are on high miles per gallon while having a moderate power region. Okay, this is what we understood from this chart. This is, for example, an informative chart. Okay, we choose our valuable variables that we want to work on it to understand the relation based on the case that we have very well, and we choose the right chart. Okay, so now let's recap a little bit. To do visualization, you have to understand two things. What variables you are willing to show and why. why you are showing this variable and what type of chart you want to use. You cannot just choose any chart. You have to choose the right chart for the right variables. For example, here you cannot just choose for example, box plot, because it won't show the relation and the comparison between the three categories we have. You see here in the scatter plot, we are showing two things, okay? The relation between the horsepower and the MPG, and we are comparing each category to the other, like the blue, the USA, the yellow, the Japanese, and the pink, the European. So now we can make our decision better, okay? So we can compare. Now, since we are like, can I say, we are putting our mind in Japanese cars, we look only to the yellow. But well, it's good to see other cars. Maybe one day you will get a American cars. Why not? Okay. Okay. Now moving to the second chart, the second part that we want to understand: horsepower trend over time. How the horsepower is going on over the time. You know, we don't want a very old car and not them brand new, but we want a good car. So we need to see how the horsepower is going on through the decades. Okay, for example, in the 70s, horsepower is different than in the 90s, in the 80s. Now like there's a lot of a sports car, for example. Okay, so what kind of plot we choose? We choose box plot. Again, you import Plotly, use px, which is for Plotly. You just call the box function. Type. What do we give for this function? We have to give some argument. First of all, you have to specify the data frame that we have. نحن هون, here we are working with the df. Okay, the x. The x is the x-axis, which is this one, the decade. Okay, then the y. The y is the y-axis. We are comparing the trend of horsepower. So we put the column that we have, horsepower. The colors, origin. You can change the colors as much as you can by featuring. You can like do other functions to like change the colors. The origin is red, then RPG, red, blue, and green. This is the origin. Okay, it's simply for the colors. Title. Let me say something one more. Always a short without a title is useless. You have to put a title, and the title is not like something very smart or I don't know what. It's just informative. Remember, you are here to share information, to share insights. Okay, so put an informative and a very easy title, so everyone who see this short and see the title, oh, this short about this. Okay, so always focus on the value, do not focus on like the trend. Okay, put a good title, a clear title, and a simple title, just like you are explaining to 5 years old. Okay, you have an image of a cat and you are telling a 5 years old kid this is a cat. Okay, that's it. This is the point of a chart. The labels here, we are also need labels. The labels here are for to know what values we have. This is our the labels: 9070s, 9080s, 50, 100, 150, and so on. You need to show the labels so we can read it easily. I don't want to like, is this a 100 or a 200? No, I want to understand. Oh, look here on the 100, the median is higher than 100. Oh, I see. That's clear. I like it. This is good. I do understand now the data that I have. Always put on a label. Okay, this is how you put a label. Just the horsepower, which is the column that we have, and give a title. Okay, so I have a question. What if a new car was produced after we did this code and it matches the requirement of the person who needs the car? Should we manually edit the code again to it? Okay, let me say something. About this question, we are talking about data. You are saying that there is a new car that matches the requirement the requirement for our client, for example. Here you are talking about real life analysis. When you have Sarah real life analysis, okay, you will always having updated data. For example, here you don't have to manually change the code. You just have to update the data. Okay, I will show you. For example, here you are using this MPG data. This MPG data is old. Okay, it's not updated. When you are saying that you have a new car that have the requirement that this client need, you are telling me there's a new updated data. You just take this data that we said about importing the data. You get the new data and you have the same analysis. This is what some people or some data analysts, they don't sometimes have to keep the data updated. Okay, so you have to stay updated with the data. That's regarding your question. I hope this answered your question. uh, okay, okay, back to the box plot. So when we choose box plot, we choose box plot, and we choose it in this way. As you can see, we are comparing two decades. So it's clear for everyone here that we have the 70s alongside, okay, or face to face with the 90s. So we and each year, so each country, sorry, each country have one box plot. Why? For this reason, okay, we can compare each decade and each origin. Okay, so this way I can think: do I need the 70s cars models or the 80 cars models? Okay, this way I do understand better, and at the same time I can understand: do I need Japanese car, how the Japanese cars are performing through the years, how it's comparing it's doing performing comparing to the American cars. What about the European? See, when you have this type of clear chart, you can have more answer questions that you can answer just by looking to the charts. Okay, so here you can see that, for example, when the box plot is going like smaller and more compact, this means the outliers are getting closer and closer. See, okay, this is for the US, for example. The blue is for the US. Comparing to the Japanese, this is Japanese, yes. Japanese, see how the median is going lower and lower? This is the median, guys. Okay. So from this analysis, what do we conclude? Okay, newer cars have higher horsepower while maintaining the MPG. You see the three box plot are more compact now. The values of the horsepower are getting like smaller comparing to the MPG. Okay. Moving to the our final chart, which is the distribution. When we are saying distribution, meaning MPG distribution by size and origin, there is a myth. I don't know if it's a myth, to be honest. I'm not good with cars. That the bigger the car, the more fuel it consumes. So let's see if it's like true or false. I don't know. I'm not good with cars. So here I chose a cute somehow a chart called violin. Okay, I'm a musician myself, so I used a violin. So a violin chart will looks like this. You see how it is look like a violin. So for this, okay, again I put the data frame that I have. What I have in the x-axis, I have the size category that we did before: the small, the mid-size, and the big. In the y, I have the MPG, and the color again is the origin color. Box, true, and odd. Okay, this is for okay. Uh, this is the box that we have in the inside. As you see, the box that we have inside the violin, and the points. All the we want all the points that we have in our dev. Okay, so okay, so this is for why we choose our violin to show the distribution. If it's like you see if it's like getting more and more thin, that's mean they are okay. If it's thin, that's mean we are getting more and more like close to each other points. Okay. After this chart, you do understand that Japanese compact card dominates in MPG. They are the best in having a they have the best like choice for like having a, how can I say, convenient MPG consuming. Okay, this is how we get from this chart. Again, have a clear chart for this. Now, uh, okay, this more feature engineering. I did this like MPG. How can I fix the MPG minimum and max, and your score? Okay, again, feature engineering. You are changing the way of your data, and here personalize large cars. I started here with personalizing the cars that I have. I composite the score. I made a score. I want. I will give 30% for the importance, for the MPG, 40 for the power, 24 if it's new or old product. I will give 10% points. I did this calculation and this composite score so I can do a leaderboard. Okay, so I can choose. And also, I did this. I did this score for the Japanese cars only, since I want just a Japanese car. How did I do that? I created a new data frame called Japanese cars, DF, which is the data frame. I took the the origin column and I filtered on three. Three is the label for Japanese. I sorted the values using sort values that is built-in function. I applied the composite score sorting for sorting, which is this one, okay, based on the composite score, okay, and ascending false. So I'm going from the biggest to the smallest, okay. Now I'm showing the top five cars, okay. Here I did a scatter plot again, and I showed the top five cars. I have in the top five cars, oh my god, Mazda. I didn't expect that. Nissan, Honda Civic, and Datsun again. Hatchback. They are all like compact. As you can see, they are compact, mid-size, compact. So I don't have large card, which is good. I do have like newest, yeah, it's newest since our data is 70s and 80s. So I have all the model years in the 80s, which is good as well. MPG is good somehow also. Horsepower, nice. And the weight. Personally, I would go for Nissan Frontas. Okay, so this is all. And I just answer if I can. I guess I will just wrap up here and I will answer the question regarding to the RAG. The one who asked about the RAG, yes, the encoding is similar to the RAG part, okay, since it's called embedding. Embedding in the RAG part, not only with the images, but also in the text data, you just transform the sentence that you have into a vector embedding, where you give each uh, word, okay, each word a weight. This weight is called embed, okay, embed value. And at the end of this embedding part, you will have, okay, in the embedding part, when you have a whole sentence, you would have a whole vector for a whole sentence. So yes, in RAG, you have to embed your data because the model does not understand images or text or anything. Okay, I hope this clear the RAG part. And if you have any more questions, feel free to reach out. I have a question about why an uncertain function she equal 3. I think she means in this one, Japanese cars. Uh, okay, okay, deal. Anyone have any more questions? And I hope the RAG part is clear. And if it's not clear, please feel free to reach out and ask any question. Please, anyone have any questions, anything regarding to RAG, NLP, data engineering, please feel free to reach out to me on LinkedIn. I'm always happy to help. And I will share my LinkedIn with you guys. So anyone have anything, they can reach out. Uh, Wait, where's my LinkedIn? Here's my LinkedIn. Okay, so feel free. And again, I want to say one more thing before wrapping up, and that guys, and when it comes to data, okay, I want you to always understand that you have to. Coding is the easiest part. Okay, coding is the easiest part when it comes to data. I am a data engineer myself, and to be honest, I found that coding is the easiest thing, while understanding how you should code, what should you should give, what you should show is the hardest part. That's why again, understanding the problem is help solving it. Okay, defining the problem. That's why I do suggest you to like focus on the business values, how you why you should do this and why you shouldn't do that, especially for anyone who's willing to enter the data engineering part. The data engineering part should understand business, should understand how they should automate the work, when they should and where they should not, and they also need to understand code. Okay, but if you cannot understand business, you won't like have a good like start when it comes to data. Understand why you are doing this, understand the data that you have, and understand the problem that you have. Anyone have any problem, any question, or like anything they want to say? Feel free. Okay. Okay. Thank you so much for having me, and bye bye.
Hello, everybody. I hope my voice is good and you can hear me well. Um, I was taught to speak about the machine learning, especially in regression and classification, and we can show some real hand work or some data. So I don't know if the voice is good and everything is okay. Um, Okay, very good. So we can start. Okay, so I will not speak too much. So I'll just show some slides. Then I will show some coding using Python. Actually, I know um, MATLAB actually very good in presenting and working with data and matrices, which I recommend actually because it can give you a good environment and very easy environment for machine learning, especially in regression. So we start with the regression. So we can say that, let's say that basic manipulation, basic analysis of the data, this is just like you make query or ask, what is this? What is that? This is the manipulation or this is the analysis. If you are looking for some patterns, if you are looking, so how many people they buy this item or how many people they visited this place, then you are looking for patterns or anomalies. So this is that data mining. What we are speaking about is machine learning, which here you build modules and you are aiming to predict. So you have some data and you are not looking for something in this data. Actually, you are looking for uh, the next version or the next part of the data that you didn't see it before, or the module that you have didn't see it before, and you look using the previous learning from, or the previous the module that you tune it to use it using the previous data. Okay, so we have two sets at least, which something we learn from it, something we build the module, and something that we want to predict, we want to know what's next. Okay, visualization, that just you have a data and you see it using different type of visualization. Okay, so either supervised or unsupervised. Supervised meaning that you have labeled the data, meaning that like you have a time series data and you say that this is in time, in day one, this day two, this is day three. For example, this is cheese, this is banana, this is apple. So you label the data. Unsupervised data meaning that the data doesn't have any labels and you look inside it. So you look on the patterns or the structure. It's similar to the data mining. You don't know anything about the data and you are looking for signals. Okay. Some people they say that they can build some semi-supervised, which data that you collected but you don't know if it's labeled or not, and some of them they are labeled. So active learning meaning that you use that semi-supervised to ask for labels. So you ask the people or ask the user to label the data. So you build a module and you build the data set that you have it. Reinforcement meaning that you develop and refine the module as the data arrive, which meaning that you can use it in real time data, like the translation, for example. Okay, so as you have here either a predicted values or a numeric output value, dependent or independent. So for example, I have here a predictor. You want to predict, you have the mother height, the father height, the current age, and you can output the height, for example. Okay, now we can say that we want to classifying meaning that we have some data and we have some predictor value or parameters, and you want to classify these people on based on the age, based on the gender, or all of them. So you give them something like probabilities, for example, if they are higher than 50, if their income higher than 100K, for example, per year, then you say that this is a buyer of the house, for example. This is the predictor value, this is the parameters that we use it, and the output is that you have, for example, the data and you classify it. You see class 1, class 2, class C, and so on. Clustering, here you group the data into sets that they are similar to each other, despite of they are a buyer or not. So it's not like classification, you are clustering the data, you are gathering the people. Okay, next, we will come back to regression, so I don't want to speak too much. The regression meaning that I have a function. It's like here, where is it? You have some points, and you want a function that will, for this point, the function will do what will linear regression. So it's like you have a function that can describe all of these points, or you gather them as much as possible, or you reach a function that describe this point or this data as you can. Why? Because sometimes the point like this, the point is everywhere. If we have x and y here, I can just draw a line. You see here, you see the point are not in the line. That's meaning that this line doesn't describe the data carefully. That's why we have what? We have some metrics to measure. Okay, so the matrix, so this is the function. You will get this function at the end, and this number are the parameters for the function. So this is the line, okay? But for example, what you see here, the weight and the height. If I have this data and I draw the line, then at this point I can say that if the person have this height, he can get this weight. Or if they are the GPA in the school at this point, then they probably will get a GPA in the university at this point. So this is what we call, we describe the data that we have it using a function. Here it is linear, just a line, and we use this line to describe more data. So we say we predict using this line. So we say that if I got 4 in the high school, that's meaning that I will go 3.7 in the university. Despite that, I can get more or less. That's meaning that we have an error. We will have an error. So we will have an error, meaning that I need something that uh, will I can measure this error. Okay, I have something else to say, that's correlation and causation. Correlation meaning that there is some value that track each other or related to each other, like the grades and the SAT score. SAT, it's international exam. The height and the shoe size, for example, they highly correlate. Correlated meaning that there is a relation between them. The causation meaning that the education level will get you a starting salary, high starting salary, or the temperature will increase the cold or related, or will cause the increase in the cold drink sales, for example. So you need to understand the relation between the values or the parameters. Okay, maybe they are reversed. So if something increased, the other one will decrease. Okay, negative correlation. Okay, so this is what we said about the simple linear regression, but we need to think about the metrics or the performance of the regression. So they say that there is the MSSE, the mean square root, which you can make the summation. Where is it? You take the distance from the line that you draw it. That this is the result of the linear regression. You draw a line, and this line should describe the data that you have in blue, the points here. And then you measure the point are not in the line. If they are all in the line, then this perfectly describe the data, and you will get zero in the errors or the metrics. However, they have different distances from the line. If it's linear regression, there is polynomial regression. We will come later. So we take this line, we measure it, the distance from the line, and we take it and we calculate it like this, and then we get the performance, which called the SSE or MNS. If we have M, then we will take the mean over the number of the data. So you don't think about it too much, because there is already some software that they calculated already. Also, there is the R square, which is another metric to measure the performance or the coefficient of determination, which is from between 0 and 1. Okay. So how? Here, correlation game, you can go to these websites and look how to guess the correlation or calculate the correlation, and see the difference or the relation between uh, uh, multiple values. Okay. And there is here the city temperature. We will see some sample here. If we have the temperature versus the latitude, and the temperature versus the longitude, and the longitude versus the temperature. So if we look at that, we will see that the data, the line you see here, sometimes it's measuring very carefully, sometimes it's the data is very far. Here, like here, you will see more here in this value, all of the data very close. Okay, so maybe you got R square value identical. So reminder, as we come to the end, we train the data, some of the data, to get the module, the O, for every type of data. Then if you got O1 dash, meaning that at this point I got this value, despite the reality that at this point I got these values, O1. Okay, but we use this data. This is what we have at regression. Do we use regression? I think yes, there is something called polynomial regression, meaning that instead of drawing a line, I will draw a curve or a function of curves, like here, a0, a1, this is the function, and multiplied by x2, x3 until xn, and or exponential regression. So you can actually not only draw a line, so because of the number of data may be very far away from the line, so I will use something more efficient. So here you see there is a problem. Maybe you overfitting if you increase the number of coefficient, or underfitting, meaning that the errors are very high. Here all of the point they are not in the line, or just right. So actually we have some software that you give the data, and they give you the function, actually. So you give the data, and they will calculate how many number of coefficient in the polynomial until they find the best one for your data. They measure adding here. If I have it a0 plus a1x, that's the linear. If I add more and more and more and more, that's meaning that I am trying to add more in the polynomial, and that's meaning that I add more coefficient. How many coefficient that I should have, that's based on the matrix. Okay, we use the least squares, we use the R squares. Okay, so If it is good, yes, we use it. Why? We use it to because it's very simple, and the module is a function of the input and the output. So you use the input to predict the output directly, and you balance the complexity to get the best fit. And also you, the closer the function fit the point, the more correlation of the measurement are, so you measure also the correlation. Regression is it has a lot of algorithms actually, not only this. So regression is very simple, you can calculate it in real time actually, so you don't have to run the machine for a long time until you get the output. But you have to be careful with the errors that you have it. So at the end you need the prediction to be good, to be as much as possible close to the real world values. Okay, so I will stop here for the regression and I will go to the classification. The classification here, we spoke about this, the machine learning. We use the data to build the module, and then we make the prediction. Either it's supervised in the regression, so you have a set of predictors, and you use to predict the output for the new predicted predictor values. And then we have something else. This is the regression. We have something else. We call it the classification. Classification meaning that you have the training data and you have set the feature values, either they are categorical or numeric values, and then you build the module to predict the new label or the new features. Okay, how we can do that? For example, these are example medical diagnosis. The feature are the age, the gender, the history. So you have like an Excel sheet, and you have all of this information, and test result one, test result two, and all of this you use it to detect the disease, or to predict that if there is a disease or not. Maybe there is already a disease, or maybe you predict that this person will have diabetes, for example, after 1 year or 2 years. The spam, either you make 100% sure, no, you probably more probable that this email is spam or not. Based on what? Based on some feature values. How we can build that? Using some functions. For example, I will give a probability of zero point 0.1 for the sender domain, and if it is the length will get zero point 0.2, and the image, if there is image, zero point 0.3. So you make the probability. When there is a higher probability that this is a spam, then you say this is a spam. After what? After some threshold. Okay, the credit card, if it is fraud or not, then you use, this is another example. Okay, what are the algorithms? There are many algorithms actually. Nearest neighbor, decision tree, naive, and maybe there is other complex like deep neural. K-nearest neighbor, KNN, you hear it a lot because it's very simple and you can calculate, you can run it directly. You measure the distance from like a line. You draw a line. After that, this is, or a point where is exactly this is a buyer, on another point this is a non-buyer, and then you put all of this data and you say, for example, they are close to that or not. So it's like you measure in 2D image the distances. Okay, so you classify the data. Okay, so here you classify a new item. In the label data, you find the key closest items to I, then assign this. So if they are, if this point close to all of these point, and you say this, all of these points are in class A, then this point related to class A. If this point close to class B, then this is in class B, in class C, in class D. Okay, so that's why they are actually measuring a distance, a Claudian distance. I'm not speaking too much about the mathematical background, but this is what we call it, Claudian distance. I think you hear it about in physics, or algebra. Okay, so you predict, for example, here we have an example. We will predict the temperature based on the longitude and the latitude. So here you will have the longitude and the latitude, and you see some cities. Every one of them, they are in the colored, here the categories. So all in these ones, you see it in here: Berlin, Bonn, Matisse. They are in the same category, in the orange one, in the blue one, and this only in one category. Okay, so how they do that? They measure the distance from for all the categories that we have it. Okay. uh, I think there is something here. Yes. Here, if you convert it to a values, here you have multiple value. So if the person is male, then they taking a value they close to. Teacher, more close. The age, the income, the postal code. If you measure the distance and you then calculate all of the distance, then you got uh, the group or the class that this data, or with these features, they are belong to this class or that class. Okay. Okay, decision tree, meaning that I will have here, you use the train to construct the decision tree, then you use the decision tree to classify, again, the same idea, to classify the new data. Here, if they are gender, you make it female or male, then a higher than or lower the age, then you go to non-buyer directly. So based on this value, you go to the next until you find, based on the decision tree, until you find the class. Okay, so from 20 to 50, you hear. From higher than 50, you hear. If you from 20 to 50, you think about the profession, which is another feature value. Then if they are teacher, doctor, other, then you classify, then you classify. Once you build this, then if you got a new data, then you just say that this new data, for example, the profession, the age, the gender, the income, the postal code, you see it where is exactly the category. Okay, maybe this is two categories actually. Maybe you have more categories. Okay, so the problem here, or the advice is to build a good decision tree. If you didn't build it well, then you stuck in a forest of many trees, or you stuck with a very far away from the real value, or from the you predict a value which is not related to the real value. Okay. Forest, it's a mini tree, and then you combine the results. This is another story. So you still have all of the trees you calculated. Then, if you have many features, for example, if you have a correlated data, or you record the same value but different ways, and then you record the first record here, the second record, the third record, and then you calculate all of them. Then you combine the results. Then, but you have here, as you add more trees, then you add more complexity to the computational, so the computer will run too much. Naive bias, they are based on some bias on theorem, but they based on the probabilities, the conditional and dependent assumption, or so if you get a new data based on the Fisher value and the training data, you compute the probability, or the possibility of this value to be in one of the classes. Okay, let's see, there is something here. You got, no, not no, this one. Yes, you compute the fraction here. For example, if it is cold, then you put the value. If it is cool, you put this is probabilities. Okay, warm, hot, and then if they are coastal line, they yes, then you put a new value, another value. Coastal no, you put another value. EU related to the European Union, then you put a value, and then after that you do what? You got something. You put France, for example, coastal line, yes. EU, yes. Which one here will get you yes and yes? You get you pick the highest value, which is here, the probability. Okay, the product of all of them, you multiply all of them, then you got 0.20. Then this is cool place. Okay, this is the category for France. Serbia, for example, you got the highest value, warm. So this is naive bias based on the probabilities that you put for each value. Okay, Fisher value. In real application, the problem is, or the challenge, that you will have thousands of features. So if you have thousands of features, then you will have to build an algorithm to arrange that or manage that. Okay, something that's useful, something that's very highly correlated, something that, so you have a lot of classification algorithm other than this. This is actually the popular one to think about the real values. Okay, to get something that's related to what you are working in, or you can reduce the dimensions. For example, if I have 100, then think about how to convert the 100 Fisher value, convert it to 80 or 70. For example, salary, bonus, options, they are come or can be combined in one, something called income. The passes, the minutes, they are can be in passes per minute, and so on. Okay, the distance, aviation, so on. Neural networks. All of us heard about neural networks. I'm not going to describe it as much, but they got the they got the idea from how the brain works, and then the brain actually work like it's getting the data. They have something like a tune values, a weight, and then a decision, a threshold. Either it's yes or no, and then it gives to the next neural, to the next, to the next. This is actually a very naive explanation, but it's like they got inspired by the how the brain works actually. Powerful computing, but it need a massive data for effective training, and it need a lot of time and powerful computing. Okay, to get some real data in real time, not working for example, your telephone or laptop for one day to get the results. Okay, deep learning meaning that I add more layers, I add more neurons. Okay, and we use it actually to use the higher type of data. For example, I have a textbook or a video or image in an unstructured data, and then I need to identify the feature, or I need to classify. Okay, so here we have something called input data, hidden layer, hidden layer, hidden, all of these the neurons and the connection between the neurons, and each connection has a value. Actually, when I studied this for the first time, we didn't have a very good computer, so our professor asked us to calculate by hand to get the output actually, from one value to next value until you get the output, how they actually classify. So you can get the idea. So that the data you cut it off with something called training data, and something called test data. So not all of the data you train on. And then you got the Fisher values like here, and then you got what? You got the labels. For example, our example here, if it is cold or not, if it is cool and warm, then I need to like a confusion matrix. Confusion meaning I don't know if it is here or there, if it is the accuracy. The for example, if it is cold and cold, I the actual value cold it is here, and the predicted it is here. Okay, so this is the line of the predicted. So you got this matrix and you got the accuracy. How you calculate the accuracy? By calculating the diagonal, the summation of the diagonal over the total values. Uh, like here, something like here. Other methods that you can see it, logistic regression, support vector machine. So there is a lot of methods in machine learning. We actually come across some interesting ones or a very popular one, very easy to build, very easy to use. Okay. So in summary, we have something called machine learning. That's meaning that the machine will decide or classify or predict using some data that you give it to the machine, and the machine actually doesn't know what to do and what are these data. So they just use an algorithm built it by the humans to predict something. If you tune it very well, then the prediction will be very close to the reality. If not, then you got out of the reality. How to say if it is okay or not using some metrics. So it's very important to know about the metrics and to measure the error or to measure the accuracy. Okay, so the module is actually a function in any programming language, and it makes sure that to give you some useful information instead of calculation. Okay, we spoke about kin nearest neighbor, decision tree. I have actually here, this slide is very good in classification, but it's give you some data set and how to work with it, the logistics, the auto. But I need to come across something here. This is one of the way to the curves, that one of the way to calculate uh, the conditions and how to calculate if it is true negative. I think you hear about that. So it's used for the all of these. They are the metrics what I said about. So they are metrics. So which one here is ROC, the accuracy, the prevalence? Okay, so here, where is it? You have to get some data. Support vector machine regularization. This is meaning that you need to regularize the data or put it within some limits. Okay, so the classification at the end you see it like that. Okay, I will show you here. I stop speaking or reading. This is a website. I think you see it. This website actually you can use it to classify the data. Here I will use or choose some data here, and I can actually change ratio of the training to the this data. So how many percent you see here I can change, and at the other side you see the output. Here the noise, meaning the data is mixed very well and there is some noises or not, like here if it is 50% or zero. You see the difference at the other side here, the data around each other, so they are easy to classify or mix it together very well. Okay, the batch size, either I have this batch size here. Okay, regenerate some data. This is data, this data actually some points, get some x and y. Okay, And then here the features. I have x1 and x2. Maybe I put the square of x1, the square of x1 multiplied x1 and x2, the sine of x1, the sine of x2. So the features of the data. Maybe these are in real life, these are the names, maybe the income, maybe the risks that somebody use it, the number of cars, the houses, the something, and you predict how many or how much they can invest in, for example, in real estate, for example. Here is the neural network in the ends, and the neural network actually it got the data from here, and then it gives you the output, which is a classification. Okay, give you the output, meaning that I have here the data and I have a weight. At the beginning, at first time, I give you a weight which is random, and then it go to the neurons, and then I will give another weight for the line and give you a neuron, and then maybe I have more hidden layers here, which will calculate more. Now, I will have something in the between, which called what? Which called a classifier or a function that will say, for example, this value either this side or this side, and then this neuron will decide. More layer meaning more accuracy, but meaning more computational. And here is the activation. This is the function. This is actually a function. I will not come through it. And the learning rate. Okay, what else? Ah, in next approach here, you see, in next approach what we will have the weight will be different, 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 the weight, it changed the weight. So then the neurons actually they change themselves to be more related to the data that you give. Okay, meaning that I am learning, meaning that I am fixing myself to this information actually. So if I give a different information, completely different information, it will give me a wrong answer or a wrong prediction. For example, if next time I give you x2 or x1, x2, it will give me a different information. Do you think people like that? Yes. If you train somebody to learn English, if you speak with them in Spanish, they will not respond, right? But they will respond only on the something that they are trained on. That's meaning that their neurons, they calculated the weight every time. They tuned the weights, they tuned their skills, they highlight the better information, the good information. They see more cases, they got experience. That's the idea. They got experience. As more inputs here, that's meaning more experience. You hear? Maybe at some point they will stop because this data is actually very simple, and we make it the noise is zero. Actually, maybe you can increase the noise, and you see. So every time you got a different weight, and then you still have the weights until you finish. That's meaning learning. Next, if you give different data, that's the test data. So you test your knowledge, you go to the exam, you think, if you got an exam, if you learn it and you very well at mathematics and you got an exam in physics, that's meaning that you got a different data. You need an exam in mathematics. That's meaning that you will test your information. If I give you the theory, if I give you some examples of the theory, if you train yourself on more examples or more problems from the book, in the exam you will get a completely different problem, but this in similar information. That's the testing. Okay, you train yourself in on the classification of the cats and dogs, but when I test, I give you a completely different image, and let's see. If you want to see it more in real life, you can see the babies. Or if you speak with a child and you say, this is a dog, this is a cat, this is, and maybe sometimes you say, no, this is something completely different or the opposite, they will respond. Maybe they will hang in the middle. That's probability. That's they don't know, or they may don't have 100% idea about the test data. Okay, this is why they inspire it then, and they call it neurons. Okay, and we stop here. Okay, I suggest for you to see this website. This is new data. You can get data from here, and you got the API, and then you collect the data. This is actually the news, worldwide news, for the past 7 years. So think about it that you can predict, for example, what will happen for the business in the UK, for example, or what will happen in the politics, what will happen in the, which country will be more important than another country, for example. So this is one of the a good website that you can use it. Here, this is another website called AI Cases. Here, you after you learn, you want to use this information. Very good. So you can think about how to use the machine learning, the AI. So you can hear this lot of examples. The retail, for example, personalized recommendation in online. For example, if you want to the dynamic prices optimization. So every time you go to the website of airline company, you see different, for example, different price promotion, how to give the people promotion. Okay. Also, this website has 100 or more AI use cases with real life example, so you can think about it. So you can use it like natural language, like predictive the maintenance of the tools or the sales. Okay, now I can show you. Can if there is any question, I will be glad to receive it. Okay, let's see some real examples. Let's stop sharing here. And I will share now. Window. Okay, share the code. I think it is shown here. Yes, very good. Here is a code, and it use some data x and y and give you the noise, so similar to what we see before, but here we will apply the regression, and we split the data to training data and testing data and the percentage of test data. Then we make a linear regression, and then we predict in the test data. Okay, so and then we calculate uh, the metrics r square and mac square. Okay, and then we plot here the plot using matplot. This is actually written in Python. If we run this one, what we will see, I think we will see something. Yes, this is the data that you have. and this is the closed form, the line, and SGD in the here. And if I got a fissure here at this point, it should give me at this point here. So this is what we have in linear regression with two idea. Now another two ways actually here, the K, NN and decision tree and linear SVM. Uh, here, yes, I got this from something called sklearn. So you can actually download it, and they have all of that. I think you all know that. So if we run it again, we will see this is the KNN. Here you have this class in yellow, this one class, this is another class, and this is another class. Okay, I actually use KNN in a real application, uh, in wireless communication. If in telecommunication, if you use that your telephone, you are connected to one operating company, for example, like Vodafone. And what if somebody unlicensed and they are trying to use the same frequencies? They have some tools to locate these people, so they can use the law to enforce these unlicensed people or unlicensed broadcasting. So how to locate them? By measuring the data that coming from this place, because they are broadcasting, and then you can classify either these people, because all of them they are emitting signals, you the licensed person and the unlicensed person. So you need something to classify if this is licensed or unlicensed in real data, actually in real life. And you got hundred millions of data some at some time in time. So we need to classify. So KNN is actually very good to classify, not to classify, to locate this person. To locate meaning that the signals, maybe here is moving from one point to another. So every some sample in time, we got information, and then we draw a line or draw a circle, and then we say that this person is here, and we can locate this person. How we can say that this person unlicensed or licensed? Because we know the licensed people. We receive from for example from the yellow person, and we know that this is licensed and the telephone number is 1234 or something, and we locate the licensed people. So the unlicensed people, they are probably in this area and they are moving. If they are moving, then we can use the KNN, because the data, we don't record the data, or we will have a very huge centers, and we need to track all the time radars. Okay, very simple idea of radars, but for locating. This is KNN, and K is 5. Decision tree, it's like you either here or there, here or there, here or there. You see the difference in the features between the decision tree, because decision tree is actually more sharp. Okay, that's why it's show you something like that. And finally the SVM, more sharp, it's like that. Okay, yes, now we will see the classification. The classification, we will see neural networks. Here we will have the data which has t-shirt, trouser, dress, coat, sandal, and you want to make to classify which class the data relate to which one. Okay, so if we run it, it will take some time, and yes, we have a problem, because yes, TensorFlow actually it has a problem with the new one. So I think this is will be okay. You see, here it take time. In the linear regression, it's working all the time. So what if I want something in real time? Then I cannot use something that will take a lot of time to calculate. In real time, I want to locate some sensitive application, like for example, in you know that there is some market, the stock market, the forex market, the cryptocurrency. You want to take a decision at femtoseconds, at very tiny time, and if the computation will take more time than that, then you may lose some point at some time. Also, what I said previously, the radars, and if you want to locate some unknown targets, then you need something that will work very fast, even if you don't have accuracy very high. For example, if I want to go to some location, and where is my friend there, you will use the friend will use the GPS. You see that the GPS sometime will draw a circle in WhatsApp, and it say accuracy 15 meter or 40 meters. If you are going to see your friend, it's 15 meter is very good. Actually, 15 meter, that's meaning, and if he's in the street, you can see him. It's very good. Okay. But I want to see the result. It gives me a 15 meter in seconds. I don't want to run a machine that will give me a circle around the location of my friend within 1 meter after 1 hour. It's not practical. Okay. However, for some other application, for example, if I got the results from our diagnosis of somebody who they are suspecting of having cancer, okay, it's okay to use the machine to run for 1 day, actually, or 2 days, to give you the information more careful. Okay, so it's actually based on the application. So here you see the accuracy as the number of epochs go on, and you see the losses as the number of epochs, and you see here the train loss, here the train loss and the valuation loss. If we close this one, you can see the confusion matrix. That's mean how many point I make confusion, if it is that or this, that or this. If I got here the label, and here some of them they got the problem. For example, I confused if it is address, but I got it here as a bag or as a shirt or as something else. But if it is addressed, a lot of them they got the correct value, which is address. Okay, so but you see the time I got epoches, for example, how many? Here they are writing the time, actually how many, 14 milliseconds, 16. So we got more time than the regression, because the regression, as you see before, it's very simple. uh, okay, I reach the end of my presentation. I will hear from you, or see if there is um, Okay, I think we can stop. And thank you all for listening, and thank you all